All right, we can get started again. Who's super excited for associative processes? Awesome, thank you. I am not. I'm sorry if that bleeds through a little bit. I have a colleague, Caroline Strang. If any of you have taken her courses before, she loves learning. She thinks it's so cool. It is cool, it's cool, it's cool. But it's pretty dry. Find it pretty dry. Have you guys learned about classical conditioning in other courses before? Yeah, okay. So, who genuinely likes it? Like, actually? Like, yeah, okay, cool. That's great. Awesome. Do you guys want to come up and... Just kidding. All right. It's good stuff. It's important to know how it works. And there are laws, there's math that you can do to show how someone will learn or an animal will learn, and that is pretty neat. I understand why that's neat. But I just want to let you know that sometimes even I get bogged down in these details. There's lots of terms. CS, US, UR, CR, what are they again? You know. So don't get too concerned if you find this stuff kind of tricky to keep up with. It's pretty normal. All right. I don't want to be a downer. I mean, it can be pretty cool. I mean, 2 people in the class like it, right? Okay. All right, it all starts with Pavlov. Right? Pavlov's dogs. Everybody knows about Pavlov's dogs. Here's a picture of Pavlov with his dog. And who can tell me about Pavlov's dogs? Very briefly, what is known? But yeah, go ahead.
He basically paired the sound of the bell with him bringing the dog's food, so when they heard the bell, it was sounded.
That's right. So Pavlov, famously known for this discovery of noticing that dogs would salivate when they heard a bell. So what was happening there was he was doing physiological experiments with dogs. He wasn't really a psychologist necessarily. But he was feeding the dogs food, and there was a bell that went off when he fed the dogs food. And what he noticed is that even when the bell ended up playing and there was no food present yet, the dog started to salivate. Right? Pavlov's dogs. Pretty common in pop culture, comes up, right? Even though Pavlov was studying things about physiology and wasn't necessarily a psychologist at the time, his contributions are important not just because he discovered this association, but because he figured out how to place this discovery into a pretty compelling conceptual framework that we still use today, right? And that's known as classical conditioning. So basically, the core of classical conditioning is that you can take a stimuli that doesn't actually elicit a response, but it can be trained or conditioned to elicit a response. That bell can make those dogs salivate, right? In the case of classical conditioning, the response is reflexive and reliably produced. Like salivating. Reflexive. And here's a nice little breakdown of these different terms, right? We have your unconditioned stimulus, unconditioned response, conditioned stimulus, and conditioned response. Okay? These are the definitions of how you would define these different terms. How does that actually look? Okay, so a classic example with dog salivating to food. So here, before conditioning, your unconditioned stimulus would be the food, and the unconditioned response would be the salivating, something reflexive, right? And at first, before conditioning, we have a neutral stimulus. So if you just blew a whistle to the dog, they're not just going to start salivating, right? It's only during and after conditioning that they'll pair these things. So during conditioning, the whistle is paired with food, and it's still going to be an unconditioned response because they're still, responding to the food in this scenario. That's why they're salivating, the dog's salivating. But then after conditioning, you could just blow the whistle and see that conditioned response. Nice little graphic showing that. In your textbook, there's this little box, 4.1, which is pretty interesting, I think, because it's showing kind of how far classical conditioning can go. Even immune responses can be boosted through classical conditioning. So pairing something that enhances an immune response with a scent, a smell, can condition the immune system to jump into action when just exposed to the scent. That's pretty powerful, actually, right? So that little case study, that little box there in your textbook is trying to show you that, look, pretty powerful. It's possible to trigger a heightened immune response with just scent exposure. Again, your heightened immune response is going to be something more reflexive, right? And this is important in the field of psychoneuroimmunology, which is a whole field of study. Psychology and the immune system. Pretty cool. Okay, so there's classical conditioning, and then there's operant conditioning. And sometimes people confuse the two, but they are distinct. Okay, so in operant conditioning, it's different from classical conditioning because behaviors are not limited to reflexes or naturally produced behaviors. And the consequence of the behavior is what controls the behavior. Get into that in a bit. So in the Thorndike puzzle box, so if you remember back a few weeks ago, I think, it's with the cats in the boxes and they're trying to open the box. That's a form of operant conditioning. So animals tend to repeat behaviors that produce positive effects and refrain from repeating behaviors that produce negative effects. This is known as the law of effect. So in that puzzle box, the cats perhaps are doing a lot of random behaviors, but once they notice something good, like the door opening, they'll keep doing it, right? Right, so I said behavior is controlled by the consequences of the behavior. What does that mean? Well, there are different kinds of consequences. I'm going to put them all up here. You got positive reinforcement, negative reinforcement, positive punishment, and negative punishment. Sometimes positive punishment is just known as punishment, and negative punishment is known as emission. So a positive reinforcement is adding a stimulus to increase the behavior. So your dog does a trick, you give them a treat. Positive reinforcement. You studied hard for a test, so you go get yourself a little treat. positive reinforcement. Negative reinforcement is removing a stimulus to increase the behavior. So let's say you told yourself, I can't play any video games until I finish studying. But then you remove that, removal of the video games, increases the behavior. Positive punishment is pretty clear. An electric shock would be positive punishment. You're adding something to decrease the behavior. Negative punishment is taking something away. This is see? I too am a human. Make mistakes. Punishment is always to decrease the behavior. Here you're removing a stimulus to decrease the behavior. Taking something away, taking the privilege away. So here's another way you can visualize that with the response and the outcome. And here, again, we're using the terms omission and punishment as opposed to positive and negative punishment. So you can see that visualized here. Okay, some terms with operant conditioning that are important to know. Discrete trials are single trials with a correct or incorrect response and a consequence. Discrete trials. Whereas free operant, there are multiple responses an animal can make, and they can be reinforced multiple times. And what this allows for is a very clear measure of response rate over time. Okay, also important to know different kinds of reinforcement schedules. So when do those reinforcements happen? There's continuous or partial reinforcement. And these are the 4 different schedules you need to know. So, fixed ratio, variable ratio, fixed interval, variable interval. Ratio has to do with amount. Interval has to do with time. Fixed is more structured. Variable is variable. So for a fixed ratio schedule, a specific number of responses is required for a reward. Whereas in a variable ratio schedule, that is variable. We'll see that in a second on a graph. Fixed interval would be that you get a reward after a certain length of time, every time. But the variable interval is that amount of time is varying. And these reinforcement schedules are important because they have different kind of learning curves. and they result in different patterns of responses. So when you have continuous reinforcement, that means you're always reinforcing behavior. The acquisition is pretty fast, but it also declines more quickly. When it comes to partial reinforcement, the acquisition is slower, but the responses persist. So this is comparing all of those different schedules, and you're seeing the number of responses, or learning, really. So you can see that variable ratio is the fastest to acquire. But it's also going to be the fastest to kind of extinguish. So it's important to know that different schedules of reinforcement lead to different rates of learning, but some of them also persist for a longer period of time, and they also have different kind of curves. So here you can see for the variable ratio, if you want an animal to learn something very quickly, it's a good schedule to use. These little lines are when they're getting their rewards, okay? So you can see how they're not spaced out incredibly, well, they're not fixed, right? They're variable. The distance between the lines is different. You don't know exactly when you're going to get that reward. Just keep pressing that bar. You don't know exactly how many times you have to press it before you get a reward, right? So what ends up happening is animals respond a lot. The number of responses goes up. With the fixed ratio, you see kind of this dip because the animal starts to expect when they're going to get a reward, right? So the rate will go up when they're getting close to the reward. Variable interval, kind of similar to variable ratio, right? The amount of time is varied, so I should probably just keep responding. I don't know when I'm going to get a reward, just keep responding. Fixed interval again, then you see that kind of, those dips, because there's an increase in responding when you're getting close to the amount of time that's elapsed, right? So you can see, animals know how to keep track of time, right? Okay. Ratio schedules. Variable. Interval. Important to know. Important to know. Probably my favorite thing about associative processes is actually superstitious behavior. So we'll watch a little video on that, on superstitious behavior in pigeons.
60 years ago, the American psychologist E.F. Skinner investigated the behavior of pigeons, rewarding them with food when they learned to peck a key in the feeding apparatus. But then Skinner set the apparatus to reward the birds at random. Now the pigeons just had to sit back and wait. But that isn't what they did. Instead, the majority developed what Skinner called superstitious behavior. When an individual pigeon, for example, happened to look over its left shoulder, and the reward mechanism just happened to click in at that point, it would have got the idea that it was looking over the left shoulder that had got it the reward, so it tried it again. By sheer luck, as it happened, the reward mechanism delivered food at the same time again. and so the pigeon was reinforced in its idea that looking over the left shoulder was what got it the reward. And it went on and turned into a maniac looking over the left shoulder. Humans can be no better than pigeons. We constantly create false positives. We touch wood for luck, see faces in toasted cheese, fortunes in tea leaves. These provide a comforting illusion of meaning. This is the human condition. We desperately want to feel there's an organizing force at work in our bewildering